Today we will start our new unit, our solutions unit, and we must start this by talking about the importance of water, because water is the basis for the vast majority of solutions due to the fact that it's known as the universal solvent, and its properties lead it to be this universal solvent. Life as we know it cannot exist without water. Water makes up 55 to 65% of your body. It is the key component of fluids that perform essential biological functions. Body fluids transport materials around and out of your body. Fluids also regulate body temperature and facilitate the transmission of nerve impulses. The fact that water makes up your body fluids and is able to transport materials is due to the type of bonds it has, its polarity, and intermolecular forces. In Chapter 3, you'll learn that the oxygen-hydrogen bond in the water molecule is highly polar, with a delta En electronegativity of 1.2. Due to the polar oxygen-hydrogen bonds and the asymmetrical shape, meaning where the electrons spend their time in a bond, making it asymmetrical, it is considered a highly polar molecule. Water molecules have the strongest type of intermolecular force called hydrogen bonding. So what is a hydrogen bond? It's an unusually strong dipole-dipole force between a hydrogen atom of one polar molecule and a highly electronegative atom. It has to be nitrogen, oxygen, or fluorine in another molecule. Hydrogen atoms develop a partial positive charge, and the highly electronegative atom develops a partial negative charge, as we see in this water molecule right here, where hydrogen is positive and the oxygen is negative. Why? Because the electrons are being pulled towards the oxygen, which would make it more negative, and the hydrogen would become more positive as the electrons are spending time closer to the oxygen in this bond. So there are two main reasons for hydrogen bonding in water. One, the large differences in electronegativities between hydrogen and oxygen atoms. Recall that hydrogen is at the very left of the periodic table, and oxygen is closer to the right side, where the electronegativity is higher. The second reason is that hydrogen is very small, which means that the positive pole is highly concentrated, which would strongly attract the negative pole of a nearby molecule, just as we see in this diagram. So the hydrogen bond between these two molecules occurs because this hydrogen is highly positive and the oxygen decided to be negative, and they would attract each other and stay together. So if a molecule can exist as a liquid or a solid, its intermolecular forces must be strong enough to stick the molecules together. And the strength of the stickiness is the attraction that increases as the size or polarity of the molecule increases. It is hydrogen bonding that provides the additional stickiness to hold water molecules together as a liquid up to almost 100 degrees Celsius. And that's where they will break apart and it would no longer be a liquid and become a gas. So, in this section you will read more properties about water. You will read pages 370 373 and complete these questions. Using Table 2 on page 371, list and give an example of 5 unique physical properties of water resulting from hydrogen bonding. And there are some questions on page 375 that you can do from this section. You will also read about solutions and their characteristics on your own and answer these questions. Number 1, what is a solution? Give an example of a solid, liquid, and gaseous solution. Number 2, differentiate between homogeneous and heterogeneous mixture. Number 3, a solution has two components, a solute and a solvent. Define solute and solvent. Give 2 examples of solutions and identify the solute and solvent for each example. Number 4, define concentration. Number 5, differentiate between a concentrated and dilute solution. Give an example to illustrate each type of solution. Number 6, what is an aqueous solution? Number 7, give an example of a liquid solution in which water is not the solvent. Number 8, what is an alloy? What is an amalgam? Give an example of each. And there are some questions on page 381 for you to do. Later, we will be giving you an assessment where you will have to know the terms that are associated in all of Chapter 8 So it's important that you do all these questions. So that's the end of this, and your next lesson will be about the dissolving process in 8.3.